All right. Good evening, everyone. Let me pull up the slides here and we'll go ahead and get started. All right. Hide this maybe. All right. All right. So everyone, welcome to the course. So if you've taken ENGR 502, which was engineering management, right now we're going to enhance that a little bit, especially nowadays with artificial intelligence becoming even more prevalent in a lot of organizations. So we'll touch on really how we augment engineering management with artificial intelligence throughout the course. So a little bit about myself. I actually graduated from CSU back in 2023. And my primary focus is program management as well as systems engineering. So some interests of mine, right? Project management, process optimization, AI systems themselves, and then the human in the loop there. So human systems engineering. And my background is within aerospace. So that's the lens that I approach a lot of problems from. A little bit about myself outside of academia. Like I mentioned, working in aerospace, I actually worked at United Launch Alliance for a little bit, supporting the NASA Space Launch System, second stage, the ICPS. And I'm currently working as a program manager with Sierra Nevada Corporation. So supporting a lot of government contracts. I listed here the Air Force, but also the Navy, really just all over the map there. So a little bit about the course as an introduction, like I mentioned, AI augmented engineering management is really focused on integrating AI into engineering management, into say project management. And the aim here, like the augmentation suggests, is to enhance decision making. So we're looking to improve project efficiency. So this course, not only are we going to take a look at more of the, I think the intuitive piece, right, using generative AI in the context of project management, but the first half of the course will really focus on artificial intelligence systems themselves. So we'll take a look at all the tools, all the terms associated with that, starting with machine learning, right? Then we'll go to deep learning, generative AI. AI agents are becoming really prevalent. So we'll have a module on agentic AI as well. So just some of the objectives as you focus on the course, hopefully by the end, you'll be able to describe the functions of AI systems, right? Agents, associated elements, and really understand even at a high level, right? What is machine learning? What is supervised learning and unsupervised learning within that umbrella and so forth? Because my whole intent here is you will be able to understand the technical pieces of AI such that you can then make informed decisions on what kind of AI tools and AI systems you should be integrating on your engineering projects. Like I said, we'll be using a little bit of Gen AI, so we'll take a look at some prompt engineering techniques to really optimize interaction with those tools. We'll identify methods of AI adoption, right? We know that some organizations, there could be barriers to adoption. One of them could be just the cost. If we're trying to develop a large language model internally, right, that costs a lot of money with infrastructure. So we'll take a look at other methods we can adopt some of this technology. And then we'll analyze human and AI system output, right? So as that goes hand in hand with prompt engineering. So we'll take a look at the output, compare it to what we as humans can produce in order to try and optimize those interactions. And then we'll take a larger picture and take a look at the current AI space, take a look at future trends within AI and how those can relate to systems engineering and project management. So a little bit about the course overview. We're here today, right? We'll always have class on Tuesdays, 5:15 to about 8. And like always, I know a lot of you are working professionals, so attendance to these live lectures is optional, right? You can hop in and out as you need to, do whatever you need to do. We'll have the recordings available if you would like to view them later on Canvas on your own. I wrote here the recommended textbook. I haven't been able to identify a singular source that captures really the essence of the course material. Like I mentioned, I feel like a lot of books are either really, really technical or they're a little bit more trivial. Hey, this is how you use ChatGPT in the context of project management, right? So really the slides here, and then I provide a lot of supplementary material on Canvas modules via articles. That's really a bulk of the content, right? So I really encourage you to at least look at the slides in more detail. You'll see they're a little bit more wordy, right? But I do try and capture a lot of the content here and then augmented by some of those articles on Canvas as well. Just taking a look at the course deliverables, some housekeeping items here. So we'll have some discussion boards, we'll have some quizzes, and that's really the first half of the course, and that'll culminate in this AI and engineering management exam. And then the second half of the course is going to be a little bit more applied. So you can start thinking of what is a potential AI initiative that I may want to implement, right? And then we'll create a project plan leveraging AI in its creation, as well as the intent being to integrate AI within your organization, within your engineering workflows in some capacity. And then that will culminate in the AI initiative pilot final project. So just a document and then an associated presentation. So taking a look at the course schedule, right? Like I mentioned here, we're in week 1. So you'll have just a sequence of discussion boards and quizzes until spring break, after which we have that engineering exam. And then we focus on a little bit more of the applied part of the course through those project assignments. So taking a look at the learning objectives, so what we'll cover this evening. So the first thing we'll do, I think it's really important to step back and just take a look at the overall landscape of AI. Define some of those key terms like I mentioned earlier, right? What is machine learning, deep learning, and so forth. And then I really want to take some time and make the argument for AI and its integration. Some folks may be hesitant about implementing AI within their workflows, organizations, right? Not just a trust issue, but they may think, oh, it's just going to replace my job, right? But I want to take a look at just inherently the cognitive limitations of the human brain, right? Human decision making to really justify the need for AI integration. And then once we make that argument, we'll take a look at the historical evolution of AI technology, see how we got from the initial perceptron, right? The initial concept of a neural network to where we are today with a lot of these large language models and where potentially we can go. We'll also take a look at how AI is being adopted across industries. So the term here, right, AI patterns. We'll see that there's several broad, we can call them use cases or areas of application for AI that can get you thinking about that AI pilot initiative. Then, like project management, organizations, they can have AI maturity models, right? Project management maturity models indicate how well or to what degree of fidelity we have robust project management processes within our organization, right? Then there's similarly AI maturity models. So we can see how well AI is potentially adopted within our organization. And that goes hand in hand with ethical considerations. And we'll have an entire module later on to discuss the ethics associated with AI. And then the last piece, I just wanted to conclude the argument here of, okay, well, we said AI could be beneficial, but now let's take a look at how AI can impact the workforce, specifically what kind of new roles it could create, potentially what roles could be augmented or replaced by AI. So really advocate the need for reskilling. And I'll mention this throughout this module, but the term of just improving your AI literacy, right? Taking this course is a great way to do it, right? But really cultivating a growth mindset within this AI environment. So with that, let's just go ahead and start with the introduction to AI. And that really starts with, well, what is intelligence, right? What is an intelligent system? Some folks might think, oh, my at-home smart thermostat is an intelligent system, right? Maybe my smartphone is an intelligent system. But there's really no one standard for intelligence. AI is intended to emulate human behavior, but again, it's really difficult, even in the context of AI, to define what signifies this intelligence. And so the real whole thought here is, well, AI could be really good at matching patterns or following rules, right? But is that inherently indicative of intelligence, right? Or is that just a system that's designed to seem intelligent? And it's just a cool argument to keep in the back of your mind here on the right-hand side in the green box is the Chinese room argument. And you can think about applying this to AI, right? is that although AI systems can process symbols, right? So you may be able to get an output that seems intelligent, right? They may not inherently understand their meaning, right? So this whole notion is that computational outputs do not imply any real intelligence or consciousness, right? And this Chinese room argument just says that, hey, you have Chinese speakers here on the right-hand side, and they may input a question through the door here. And there's an individual who just speaks English, right? But is able to match the symbols and translate more or less, right? And then provide an output back to the native speakers in Chinese. And to them, they might think, wow, what an intelligent Chinese speaker, right? But inherently, the individual in the room is just matching symbols and identifying patterns, right? It's not really signifying real intelligence. So in its current state, AI really excels in domains where there's sets, rules, and patterns, right? Maybe there's probabilities. So organizations that do operate in this well-defined space can have an immediate impact by leveraging AI in its current state. But one can argue, right, that AI current applications are really what we call weak AI, because the strong AI, that term, references true human-like systems. So if you're thinking really sci-fi technology, right, that is really strong AI, maybe a system that can fool the Turing test. And then throughout all of these slides, just as a note, right, you can see that, there's a link to all of the sources if you're interested to learn a little bit more about any of these terms or some of the graphics that we're looking later on here. So now that we kind of understand, well, what is intelligence, and maybe these AI systems aren't inherently intelligent themselves, right? Let's take a look at the broader environment overview here. As a term, AI is just a field of computer science that's focused on developing these systems that can perform tasks that require human-like intelligence. So think about language comprehension, right? A good application could be translation, like we saw in the previous slide. Learning, right? Applying reasoning, trying to solve problems. So we can see on the right-hand side here, within that AI umbrella, we have several other subfields in AI. And we'll touch on each one of these individual modules, but at a high level, you have machine learning. And that uses advanced algorithms to really detect patterns in data sets, and that can subsequently lead to really useful applications in project management. Think about project forecasting, for example, right? You can leverage the data that we're collecting, right? Let's say actual costs, earned value, right? Planned value, and perhaps make better extrapolations using some AI systems. Then there's deep learning. That's a subset of machine learning. Really, the difference here is now you're using what we call neural networks, which are designed to mimic the structure of the human brain. We'll again get into how they're constructed in several other modules. But these are really the foundation then for generative AI, which is, say, the large language models, right? Generative pre-trained transformers, and some of these other tools that we're more accustomed to interacting with, most likely on a daily basis. So taking a look at more of the AI hierarchy in a little bit more detail, right? So we started with AI, we had the machine learning, specifically focusing on algorithms, deep learning, where we have neural networks, and these neural networks can have multiple layers. They can be the multi-layer neural networks, and they're really good at advanced pattern recognition. And then from there, we have generative AI, right? We're still using algorithms and models. We can have data analysis techniques. And the whole point here is, as the name suggests, you're generating novel content. You're generating an output using these tools. You do that a lot of times using a large language model, say a generative pre-trained transformer, which is really what ChatGPT is. Generative pre-trained transformers in their traditional architecture usually have an encoder and a decoder. And ChatGPT, for example, just uses a decoder type of architecture. And we'll, again, get into all of that as well. But you can see just the flow of how we get from this broad AI umbrella all the way down to these discrete applications and tools that we can use. So more terminology, definitions. Again, we touched on some of these, but machine learning, for example, right, consists of algorithms. So they outline rules and steps to make predictions. So you might have a data set that is fully labeled, right? So you may use a specific set of algorithms in that case. You might have a data set that's not fully labeled, right? So you might use a different set of algorithms to then help you make decisions based on that data. Then you have deep learning. So again, it's that subset of machine learning. You're using neural networks that contain algorithms modeled on the human brain structure. So more advanced learning and data interpretations can be used by leveraging neural networks. You have generative AI, so you're using advanced algorithms, data analysis, right, to produce these creative outputs. And a lot of times, it's not just limited to text. I'm sure you've used ChatGPT or similar tools, generative AI, right? You can have a voice output, right? A video output, an image output, code, right? There's lots of different outputs that these systems can create. Then you can have large language models, right? So they're also based on large databases that contain information. Some organizations, they create their own large language models using their own data. Sometimes you can, instead of spending a lot of money on that, right, leverage another organization's, a third party's large language model, right? And we can talk about potential risks, right, associated with that later on. Then you have those generative pre-trained transformers. So like the name suggests, pre-trained, you're using a pre-trained neural network to process large data sets to understand and generate human-like language. And then as an example, like we saw in the previous slide, going all the way down, you have ChatGPT. That's a variant of the GPT model that uses architecture for conversational interactions. So say a chatbot, and we can automatically think of many applications I'm sure you've interacted with on organizational websites where they have the chatbot that does a little bit of an FAQ type of an engagement session with you, right? If you have a question, those are all these AI tools here that we're talking about as well. So let's dive into each one of those in just a little bit more detail for some context, right? So that first one under the AI umbrella, machine learning, it's that broader subset that enables machines to learn from data. So you're trying to recognize patterns with minimal human intervention. And you can see here there's four main subsets within machine learning, like we'd seen in the figure. There's supervised machine learning, there's unsupervised, semi-supervised, and then reinforcement learning. We'll touch on these more next week, but at a high level, it really depends on how well your data is labeled, right? If your data is labeled well, you might want to use more of a supervised approach compared to unsupervised, right? Maybe there's a mix of both. So you use a semi-supervised approach. And we'll talk about the importance of data, preparing data, right? Cleaning data, because with all of these tools, they're great and powerful, but you can imagine if your data is bad, then you're going to get a bad output regardless of how good your algorithm really is. So taking a look at that specific life cycle for machine learning, if you're looking to apply it, right? So you want to define the problem first, right? What are we actually doing? Why would we actually want to apply machine learning to try and arrive at a meaningful solution? Then we have data gathering. So once we identify our problem, well, let's find relevant information. And this could be maybe organizational documentation, right? Maybe you have an engineering application, so you're leveraging maybe sensor data, right? Maybe you're looking for online resources. So you want to create this comprehensive data set to then leverage machine learning on. Then once you have the data, well, we need to prepare the data. So that really entails pre-processing the data to remove inconsistencies, right? Maybe you have missing values, and ultimately you want to format it to ensure that the resulting data set is going to be of high quality. Then you can actually conduct the data analysis. So you can explore patterns or relationships, and it can really help guide the choice of your algorithm, right? Do you want to use a regression algorithm, classification, and so forth? What is your end objective, right? And there's different branches of algorithms that we can use to then uncover those insights. Then we select our model and then training, right? So depending if how well our data is labeled or not, right? Leveraging supervised or unsupervised learning. And then we apply our algorithms to that clean data set. And then we need to be able to predict or see how well the model does on our actual data set so we can accurately determine how well it's doing on unseen data, right? We'll talk about having a test data set, right, which could be a subset of your broader data set because we really need to evaluate our model accuracy, right? Is the algorithm we choose, is it effective? Is it predicting well enough? And we can see the answer more or less, right, within our test data set. And then we can refine, fine tune some of those parameters, right, where we need to, such that we can be confident in applying the model to more generalized unseen data. And then the seventh step here, deployment. So you actually use the model in a real world environment, right? So then you begin to make those predictions. Then touching on deep learning. So like we saw in that first graphic, that deep learning, it's the subset of machine learning. So you're using what we call artificial neural networks, which are modeled after the human brain. And we'll talk about the neurons in the human brain here in a few slides. And these networks help handle more complex data and tasks. So these models, they learn patterns and make predictions using larger data sets than strictly machine learning methods. And the main difference between the two is, again, in the neural network depth. So think about those neural networks having many layers. Some of these models have hundreds, right? Thousands of layers, which can further refine their predictions, right? Compared to a simple machine learning approach. And just some on the figure here on the right, some applications in deep learning, right? Maybe your respective fields, right? Maybe you're in cybersecurity. There can be certainly applications there, right? Robotics, you have natural language processing. Maybe you're in more the agriculture space, right? There's a whole set for smart agriculture. Healthcare is also a really big one. Business intelligence, right? Touches a lot of potential fields. Then there's natural language processing. You can see we didn't look at it on the first slide, but it is a little bit of overlap with machine learning, deep learning, and generative AI. But it's really also, again, a subset of the broader AI space that's dedicated to creating systems that work with human language. So this enables machine translation and conversational chatbots, right? So like we mentioned, many organizations implement those on their websites, right? So that involves natural language processing. So just helping leverage linguistics rule-based modeling of human language. We can see, we'll talk later on how words are often tokenized, which just means broken up, and then vectorized such that you can then process them in a computational way. So this, what we call natural language processing, really facilitates communication between computers and humans via natural language interactions. And that's really the main appeal of generative AI, which is what this NLP helps augment, is that you don't need to be a coder, right? You can just go into your ChatGPT window, type in human language, human text, and get a human text response. So it really reduces the barrier of really engaging with this type of advanced technology. Then getting down to that next layer, so generative AI, right? We touched on it a lot. It helps create text, images, video, all sorts of different outputs, depending on what you as the user are asking. Gen AI can learn from patterns in existing content, right? And generate new, similar content. And that is all based on your training. We can see in the figure here that generative AI, it relies on deep learning approaches. So we still leverage those neural networks to generate that new data. And specifically, there's some unique tools you can call maybe these approaches within Gen AI. Like I mentioned, large language models, and then you can have transformers, which is what a lot of those tools like, say, ChatGPT are a part of. But likewise, and we'll talk about these applications in more detail, you can have variational autoencoders, which can help generate imagery, right? You can have generative adversarial networks, which can help generate data. You can have diffusion models, and there's some other tools as well, like hybrid models. And that's really a focus because now you're leveraging majority of these tools and creating new approaches within Gen AI. So that was a little bit of an introduction with the various subsets within AI. So now remember, based on the learning objectives, wanted to make an argument for the use of AI. And that really starts with understanding the human brain, its abilities, and its capacity. So taking a look at here on the right-hand side where we just can see a schematic of the brain, But you can see here that the brain, it really manages memory, right? Emotion, thoughts, touch, and really every procedure, right, that controls the human body. So the human brain is actually can be compared really constructively with many modern computers. So specifically, the cerebral cortex in the brain, it's the outer layer of the cerebrum, and it's really responsible for these higher level cognitive functions like memory and reasoning, right? And just a little bit of anatomy here. There's synapses, which are connections between neurons in the brain. And there's within your brain actually about 125 trillion of these connections. So you can think about the just massive amount of data storage that can be within your brain. And to put a number on it, experts actually try to calculate the storage by gauging those connections right between the brain cells. And they try to put it in terms of computer memory units. So your capacity of the human brain is actually about 2.5 petabytes of memory capacity. And just clarifying how insane that is, right? A petabyte is 1,024 terabytes, so really a million gigabytes. So think about, for comparison, right? You can have 2.5 million gigabytes of memory in your brain, whereas some of our iPhones, right? They might have 512 gigs, maybe 1 terabyte, but ultimately, even our technology is 2,500 times as small, right, as the human brain. But that's all to say that there are still some limitations, even though we have this potential for storage within our brain. And that deals with human cognitive processing, right? Human cognitive ability, it's really the range of mental skills and processes that we as humans possess. And there can be influenced by biological factors, right? Social, culture, basically our broader environment. Specifically, when it comes to human cognitive processing, there is four main elements. There's sensory memory, we can see here in the figure on the right-hand side. Then there's going to be working memory, and that leads to short-term memory. And then on the bottom here, long-term memory. So just defining these first, right? Sensory memory, just a buffer. So it's for the incoming sensory information. So your brain's constantly inundated with sights and sounds, right? And it automatically thinks about, well, should we just forget something that we saw, right? Or should we transfer it for further processing? Is this input that I'm receiving important? And that goes to working memory. So this is a dynamic system that holds and manipulates information during your cognitive tasks, right? Maybe you're working on a drawing update, you're writing a system specification, an ICD, right? Whatever, which involves this attentive attention and processing. So this working memory is strongly correlated with intelligence and higher cognitive abilities because you're retaining what you need, right, as you're creating an output. Then there's short-term memory. So this involves managing small amounts of information for brief periods without necessarily manipulating it, right? And it's characterized by temporary storage and a rapid decay. You maybe want to keep in mind an appointment that you have later in the day. You don't really manage it, right? But then you forget about it soon, right? The appointment happens, right? It's no longer relevant, it's gone. And that takes us into long-term memory. And this is more of the vast, really durable storehouse that we alluded to on the previous slide of knowledge and these past events that's essential for retaining information. So it's really important that you have your long-term memory to then be able to leverage your knowledge for future use and future applications. So that sounds really great so far, but what are these actual cognitive ability limitations now that we know the types of memory, right? Specifically, you can see here on the first bullet is that the actual amount of working memory that we can function with is inherently limited. And research has shown it's actually limited to 4 items at a time. So maybe think about 4 unrelated words, numbers, right? Imagine someone trying to give you their phone number and it's however many digits. And after maybe the area code, unless you're writing it down, most often than not, you might need them to slow down and give it to you in 3 or 4 digit chunks, or maybe you need to at least read it back, right? And this is because since this working memory can only handle these 4 meaningful separable units of information at a time, it may be important that we leverage tools like AI, right, to offload some of these cognitive demands. There's still, again, scientific debate about all of this, right? But overall, people can hold more information in short-term memory by chunking these small pieces into larger, meaningful units, right? And using tools like, again, AI can help us offload some of this, you could say maybe some more administrative information and focus more on inherent creative abilities of the human brain. So neuroimaging studies suggest that different brain systems are involved, right, when you're leveraging your cognitive ability. So you have short-term memory, and this engages, again, sensory and language areas. And then working memory relies more on your prefrontal cortex areas that are responsible for decision making. So route really tying into the need for AI, right? So we know that the amount of information in the world, the digital universe even, right, is expanding exponentially. And in 2013, the digital universe was estimated to contain about the same number of digital bits, right, as there are stars in the universe, which, again, just reading that, it's just insane to imagine. And of course, this is growing exponentially. So we're thinking that by 2025 and beyond, this can continue to increase to 175 zettabytes. And just to show in the green here, right, what a zettabyte really is, right? How many bytes. So just to think about it, there's approximately 129 million books in the world right now, and the human reading ability within, an entire lifetime, unless maybe you're a really avid reader, is about 750 books, right? So having a tool to process a lot of this information for you such that you're not overwhelming your working memory, right, can become really advantageous. And that's what the bullet here in the bold really emphasizes is given, again, the limitation of our human cognitive ability and the never-ending expansion of information, right? Think about if you're in this CSU program, doing your doctoral studies, there potentially even within the AI space, right? There's new studies published almost every day, multiple times a day, right? So how can you keep up with this? Maybe you can have a tool that can pull some of this information and present you with summaries or key concepts, right? New breakthrough revelations, perhaps, that you're focused on, right? So you can have an assistant, a system that can help you understand, process, and create information. So hopefully that really shows you the need for AI, at least from the limitations of the human brain perspective. And we'll touch on it more from an organizational perspective in a few slides. But now that hopefully you're interested more in AI, well, what is the AI hierarchy of needs, right? You can see on the right-hand side here, this is actually really similar to Maslow's hierarchy of human needs, but this really outlines the foundational steps for effective AI and data science. So what do we need to do, perhaps as an organization, right, or as a AI initiative in order to be successful? So we start at the bottom here with collecting. So you want to collect raw data through different methods, whatever makes sense for your application, right? Maybe you use sensors, right? Maybe you have user-generated content, maybe you have documentation, right? Whatever it is. Then you have the second step here, which is moving and storing. So you ensure reliable data flow using infrastructure pipelines so you can handle structured and unstructured data. And then once you have your data, more or less, this is like the machine learning lifecycle we talked about, right? You want to explore and transform. So you clean, detect, right? Maybe find anomalies, really prepare the data to make it suitable. Then you aggregate and label the data. And then ultimately you then leverage here. You can see only at this step now at the learn and optimize, are we really leveraging AI, right? Well, you're applying maybe simple machine learning algorithms to start. And then maybe as you get more advanced, you maybe have more data, you want greater insights. That's what you can really leverage neural networks and deep learning for. So I mentioned in one of the objectives that there's several use cases for AI. especially within organizations and creating projects that supplement AI within the engineering management space. And they're known as patterns of AI. And we can see that in the figure here. So starting with hyper personalization, right? So this pattern, this we can call it potential area domain of AI projects, uses AI to deliver tailored experiences recommendations based on individual user behavior and preferences. If you do online shopping, right? Even Amazon, you might get suggestions. Hey, you bought this 2 weeks ago. Should you buy this again? Or you bought this product. Here's a similar product that can maybe, enhance whatever you're doing at home, right? So there's these hyper personalization areas that organizations can focus on. And you can imagine that can drive customer satisfaction up, right? That can generate more revenue. So lots of areas there. The second one in the purple there, recognition. So this refers to AI's ability to identify and categorize inputs. So like images, speech, handwriting. So maybe think about cybersecurity or even airport security, for example, right? If you've gone through an international, right, customs station, sometimes they have those portals that don't even have officers anymore, right? They just scan your face, you scan your passport, they recognize you. That's an application of the recognition AI system. The one in the green there, the conversation, excuse me, and human interaction. This can involve AI technologies that communicate with people using natural language. So we mentioned those before, like the chat bots that you see a lot of organizations use. Then the next one there, the predictive analytics and decisions. This can apply AI to analyze past data and anticipate future outcomes. So this is very broad, but you can automatically see how this could be beneficial in project management, where maybe you're projecting your project performance over time, right? In systems engineering and creating a system, and maybe you're thinking about future reliability, right? Maintainability of the system. What's going to be the mean time between failures for components, right? Leveraging some of that predictive analytics. Then you can have goal-driven systems. So this enables AI to learn through trial and error to accomplish specific objectives. And then more of the advanced version of AI, and unless your organization is really good at this, maybe don't start with this one, but you can have autonomous systems. So these rely on AI to perform tasks and make decisions with little or no human involvement. Great application here is Tesla, right? And their self-driving vehicles. You can just turn on the self-driving mode and it goes, right? It's an application of AI where you're leveraging sensor input, right? And the system automatically adjusts maybe how you're driving, the speed, right? Turn the turn signal on, whatever you need to do. And then the last pattern here of the 7 is just patterns and anomalies. So you can use AI to identify trends or detect outliers in data. You can imagine this is really useful in cybersecurity, where you might have a system monitoring for potential threats, and then maybe there's an anomaly, right? Maybe someone didn't have access, unauthorized use, and that can potentially flag a threat and allow you to respond quicker, right? Maybe in a manufacturing application, you can have more or less a control chart, and then you can see any outliers, any potential defects on an assembly line using this type of pattern. So definitely a lot of use cases for AI here. So I know the class is relatively small, but just want to take a few minutes here for a little bit of an activity, given the definitions we've gone through so far, is consider the domain of AI, right? And some of those high-level concepts, deep learning, right? Machine learning, and so forth. So 1 to 2 sentences, maybe identify a real-world problem or inefficiency within your space, right? Maybe engineering management, academia, right? That could be improved with AI, and then describe how AI could transform the current process, and maybe given the limitations that the process itself has, or even human cognition. So I got about 10 till the top of the hour here. So maybe let's take about 5 minutes and then we can come back. And if you want to share, you can share some examples and then we can move on. So I'll pause here and we'll see you in about 5 minutes. All right, I think it's more or less been about 5 minutes here. Does anyone care to share? Maybe starting with the first one, right? If there's a real world problem or inefficiency, right, that you think could be improved with AI. I saw there was a comment in the chat, but just wondering if anyone else has any thoughts there. But Jonathan, right, looking at your comment there, so software engineering, right, writing some software tickets in Jira can be a hassle, right, time consuming, and a lot of times you have to rewrite them anyway. So maybe have an AI assistant, right, to help with the ticket writing process and maybe even reduce redundant tickets. And I think that could be potentially a really useful use case. What kind of pattern out of the ones that we talked about, those seven, do you think that would fall under?
I don't know exactly the specific pattern that it would fall under, because we have a wide range of tickets sometimes. Right now, we're just kind of into maintenance work.
Right.
So more or less just like fixing repeated issues. Um, I'm thinking maybe it's like recognition, like since patterns is a huge thing that comes back up in AI, having that recognition of, oh, we've already approached this because a lot of our applications, we end up redoing the same work. So a ticket will be done on one application that we'll just end up having to do in another one.
Right. And I think also maybe even on the conversational human interaction, right? A lot of these potential projects and applications of AI, they can touch on many of these, right? So now I think that's it's a really, really great input there. Anyone else care to share any thoughts? Right. And I can share one from potentially one of my examples, right, is proposal writing, right? A lot of times, depending on the customer, right, maybe we're creating an Air Force customer proposal, maybe the Navy, right? Maybe a program that's worth $5 million versus $250 million, right? There's different sets of criteria that need to be met for these types of proposals. So maybe leveraging a little bit of that hyper personalization pattern, even, right, depending on the end user, but leveraging AI to at least generate a template, right? Maybe populate some fields, suggest some ideas, right, for some of those proposals, maybe leverage the lessons learned database and see what went well for similar proposals of that type of customer or dollar value, right? Such that that can increase our level of success, right? Because I know personally, sometimes there's a gap between different types of proposals. You're not always working them as a program manager. So I may forget what's required, right? What approvals are needed, right? Limitations of human cognition here. So having a tool that can help augment that would be great. Any other comments before we press on here? All right. So now that we made the case for AI, right, some potential applications, just wanted to take a few slides to look at the historical perspective on AI and how we got to where we are today. So specifically, if we want to understand AI's future trajectory, we really need to understand the historical perspective, including the technology that supports our AI infrastructure in order to really see how it has transformed societies and industries. So taking a look at the artificial intelligence evolution here, you can see on the right-hand side here, but it really goes back even before the figure here, but to 1932 with the concept of a mechanical brain, right, to potentially translate languages using punch cards. So having this first concept of even a mechanical translator. And we can see in the figure in the 1950s, Alan Turing had a paper called Computing Machinery and Intelligence, which really introduced the idea of machines imitating human reasoning. That's where that Turing test comes from. And this lays the foundation for modern AI applications. A lot of times, researchers will cite the 1956 Dartmouth Conference as really the birthplace of AI, because this really led to the formal establishment of AI as a field of study, and which led to what I mentioned earlier, right? The first concept of an artificial network, right? A neuron, what we call the perceptron, back in 1957. Then you can see in the 1960s, right, AI expanded with applications like that natural language processing. Specifically, there was this system called ELIZA, which in 1996 helped create human-like problem-solving programs. And then, of course, we can skip a lot of these, right? But even fast forward to the 2020s, right? And we started to create these powerful, we can call them large language models, right? GPTs, such as the ultimate Chat GPT application, right? In the early 2020s. And that also ties into the technology market evolution over time, right? Because we know that AI technologies today and all the infrastructure associated with them, they're built on decades and decades of innovation. And again, some of these key milestones date back to the 1960s. And really, the backbone of some of those AI technologies was really in the 60s and 80s with innovations in semiconductors, right? Operating systems and networking. So the 1990s to the 2010s then built on this foundation, right? You can see in the figure here with the internet infrastructure services, right? Mobile technologies. So now you're being able to connect with individuals on a global scale, right? The invention of the internet. And then by the 2020s, we had all these cumulative advancements that enabled the rapid growth of AI technologies as we really know them today. So some data processing milestones. I think again, it's really important to see how this all relates to generative AI. But back in the 1800s, right, it was all manual data processing. It's pretty neat here, just a cool fact, right? But if you recall, the US does a census a lot of the time, and you have to tabulate all that data. And the 1880 census actually took 8 years to complete because you're doing it by hand. This was really augmented in 1894. We got a tabulator invented, and it was actually able to use those punch cards to rapidly process and analyze data. So the census was completed a lot quicker, right? It didn't take 8 years this time. In the 1920s, you had human computers, so you can have actual humans perform those labor-intensive data calculations, right? The data processing. And then in the 1940s, that's where you can see in the figure computerization really begins. You go through the instruction capture and efficiency in the 50s and 60s, all the way to the rise of desktop computing in the 1980s. And then really the 1990s, making it even more user friendly, right? Having graphical user interfaces, really popularized by today's giants, Apple and Microsoft, and really promoting personal computing, right? Which can really lead to having a smartphone that has ChatGPT, right, in our pockets. So in parallel, like taking a look at some generative AI then technology milestones, we can see this some of this started in the early 2010s with AlexNet that showcased deep learning superiority in image classification. And this really started the modern deep learning revolution in 2013, right, 2014, 2016, this kept building until in 2017, and we'll look at this paper later on. Google released this Attention is All You Need paper, which introduced the transformer architecture. And this was then really beneficial for subsequent work that OpenAI did for ChatGPT, right? Remember to use that transformer architecture. And really, the key thing here in the bold is a lot of researchers say 2022, right, was the breakout year for generative AI because that's when ChatGPT was really popularized. And this was because, again, that natural language processing element. It was this conversational AI, right? Some of us without a coding background can now engage with these powerful tools for a lot of those use cases, like we saw in the patterns of AI. And now it's ended in 2025, this chart here, but now even in 2026, right, GPT is on version 5, right? So it's continuous, these new milestones and even more advanced models are coming out. And we'll take a look at a lot of the Gen AI tools, actually part of the project that you're going to be working on. You don't have to use ChatGPT for some of the Gen AI pieces that we'll touch on. You can use, and I encourage you to try other Gen AI tools, right? You can try Llama, you can try Gemini, right? You can try Claude. If there's any other tools like Grok, right? There's lots of those out there to really compare their different models and outputs and see maybe which ones are better to use. And this really takes us to adoption rates because I think like we were trying to make the argument for the use of AI and even Gen AI within organizations, right? Is to see just how quickly ChatGPT became adopted, right? We can see in the figure how quickly some modern technologies were adopted, right? We can see electrical power, right? Well, it went from about what 15% adoption in the call it early 1900s to 100% adoption, by a little over 1940. So you can see that's, let's call it 30 or 40 years, right, for everyone to adopt electrical power, right? The automobile, right, or late 1910s, and not everyone still has a car, right, in the 2000s. But what this is really getting at is you can see the internet, how much of a spiky curve that was. That was, maybe 5 years, and a lot of individuals are using the internet. But the note here is that ChatGPT reached 100 million users within 2 months, right? So just thinking about how quickly some of these generative AI tools are being adopted is really mind-blowing. And that's, again, highlighting the opportunity in that space, not just entrepreneurial, but also leveraging that within our unique context, project management, right? Engineering, and so forth. So I wanted to touch on a little bit the AI technology ecosystem so then we can see maybe potential use cases at each one of these ecosystem levels that maybe you within your organization can further pursue. So you can see here, there's the AI and machine learning infrastructure. That's the very bottom. Maybe think about more of the hardware, right? You have AI enabling technologies. You have horizontal applications of AI. So these applications can span multiple industries, healthcare, agriculture, right, aerospace, and so forth. And then you have industry specific, so those vertical applications of AI. And inherently, each one of these layers builds upon the capabilities of the ones beneath it. So really understanding, again, how some of these vertical applications are really, again, built on some of this foundational infrastructure that everyone uses. So let's start with that AI and machine learning infrastructure, right? The most basic. Again, all of this is linked if you're interested in learning a little bit more. But this is the foundational layer. So this again includes the platforms that support data analysis and the development of AI models. So these types of systems, right, they cover the tools for data preparation. How do we transform it to ensure that there's quality input for those higher up AI enabling technologies and other AI systems? So this also includes model development environments. It involves deployment tools, right? It also, like I mentioned, includes the hardware. So we're talking GPUs, right? TPUs to really accelerate AI processing. Then that next layer up, we have now the AI enabling technologies. So these provide the core technical capabilities that power broader AI functionality, right? That you can then leverage across multiple domains. So think about natural language processing technologies. So maybe then again, you can leverage a natural processing technology for a chatbot application, and that again spans multiple industries, right? AI enabling technologies can also encompass computer vision systems, so machines can interpret visual data. It could also offer speech recognition tools, right, like our iPhones that use Siri. It can also include machine learning frameworks, right? So thinking about the actual algorithms and data libraries that are then essential for building discrete AI applications. And again, here you can see some broader categories under, I know it's hard to read, under natural language understanding, right? Machine learning platforms and so forth. Then you have those horizontal applications of AI. So again, these are the AI solutions that are broadly applicable across many industries. So maybe customer service automation. So like we mentioned on the previous slide, we leverage a natural language processing technology to create a chatbot. And again, chatbots can be used in healthcare, right? Scheduling appointments, really anything. It could also provide predictive analytics systems. We touched on how predictive analytics is a pattern, right? Is a potential set of use cases for integrating AI. Well, this is that horizontal application can actually be that system. So it can help forecast future trends and behaviors. It can also support robotic process automation, right? And maybe on a more specific case, right, fraud detection, suspicious behaviors, and you can see how that could be applicable, maybe at a bank, right? Cybersecurity applications and other industries. And then finally, that most niche layer, we can call it, is industry or domain specific applications of AI. And this is really focused on AI technologies that you can tailor to meet the needs of your specific industry. So maybe you leverage a horizontal application within healthcare to help diagnose and create personalized treatment recommendations. It's actually really cool. I saw, and I'll usually post announcements with interesting articles because, like I mentioned, this is evolving every day. But ChatGPT is coming out with a GPT Health feature, right? I haven't played around with it. I don't know if it's currently active or not, but you can imagine such a large language model, right? A GPT can then be providing maybe more customized treatment or recommendations based on what health information you share with it. That can get into privacy concerns and so forth, but at least that's a very interesting application. Some more domain specific applications, right? Financial tools for, say, credit scoring. Maybe you want to try and beat the market, right, with your investments. So some sort of algorithmic trading. You can also support manufacturing with systems for predictive maintenance. Like we talked about, maybe now I have a aerospace specific for a specific aircraft platform predictive model powered by AI to tell me when some of my components will fail, when I could then plan my maintenance around, right? It can also aid agriculture with tools for crop monitoring and so forth. Basically, you can see here again a lot of personalization based on discrete industry needs. So if you're looking for some opportunity and where you can actually create new AI systems, there's three key opportunity layers. So there's the infrastructure layer, the development layer, where we're talking about the actual data, right? The tools. A lot of organizations like Scale AI, right? They're really looking at trying to get as much data as possible to then create a lot of different models. And then, of course, the application layer. And just touching on the bottom bullet here, that the application layer offers the most opportunity because there's low barriers to entry because you can leverage other organizations, that third party here, infrastructure and development layers to then build your applications on top of. So that could be reduced cost, easier access, and subsequently you can have a larger impact, right? Maybe we create an application specific to, like I mentioned, the example of the aerospace, maintenance for specific components, right? Built on top of existing infrastructure. Again, all of this is linked, but just wanted to have this changes all the time, but a generic Gen AI market map. So we know that the technology is continuing to evolve from conceptual items to actual use cases and value. So this really creates and increases a multimodal nature of Gen AI applications. So maybe if you're looking at consumer applications, right, maybe in the social space, right, or maybe more of an enterprise horizontal applications, right, for marketing. There's a lot of, right, potential vendors. Maybe you're looking more of a vertical use case within your enterprise, right? And maybe you're, in healthcare, legal. We'll talk about Harvey and some examples as well, right? There's different tools out there available. And then same light here, the Gen AI infrastructure stack. In this case, the image here is a large language model developer stack. So this really reflects the compute and tooling vendors that organizations leverage as they build their Gen AI applications in production, right? So you can have your apps and workflows, right? Developer tools. We'll talk about model tuning, right? So refining some of your model parameters. Data labeling could be a subset of that, right? Having some vendors here. The compute and interface, right? Foundational models like text with GPT-4, right? You can have Claude built by Anthropic and so forth, right? So there's a lot of vendors out there, and just getting familiar with the space is really important. I want to talk a little bit more about the large language model timeline since we were talking a little bit about Gen AI. Specifically, right, recent breakthroughs in large language models have been driven by transformers and especially on the hardware side as well, like you saw in the overall timeline of some of these tools with greater computational power and being able to process large scale data. We have been able to build in a very short time frame, like you can see in the figure, these large language models that achieve near human level performance across a large set of diverse tasks. And what this figure really does is it shows open source large language models and then closed source large language models. So open source, right, they publicly release, their model weights, their code, training data, and weights refer to maybe some of the neural networks, right? What specific parameters they place emphasis on, right? The code, obviously, and then training data. So this can allow you as a developer to fine tune it a little bit more freely. Whereas if you're using a closed source large language model, like say GPT or Claude, right? All of that secret sauce is just what it is. It's proprietary. So it really limits your customization and transparency. So if you're thinking about integrating any one of these tools, right, it could vary between, well, do I want something open source or do I not really care about customization? Maybe I leverage something closed source. Mentioned that other subset of AI, right? AI agents and generative AI tools, right? What are the differences between them? So just we'll have a whole module on this, but an AI agent, right? It's part of agentic AI, which is a branch of autonomous systems that can independently plan and tasks and achieve goals. So think about agents, right? These AI tools that are working together autonomously, right? Orchestrating specific tasks. So maybe generating content, right? Responding to tasks, learning patterns, really acting independently. So you can see here, Devin, just some tools here. Devin is an autonomous AI software that can help debug and actually ship real world applications. So you can have natural language processing, you can instruct it and it can build something, software for you. There's Harvey. So if you're working on, is this the legal one? Yeah, I think this is the legal one. So if you're working on maybe a case, right, you can leverage Harvey to help design a specific legal document. Then you can have Microsoft Copilot, right? All these other ones that are really similar to chatbots. So those are those Gen AI tools. And then you can also produce images and videos. So HeyGen is a really actually interesting platform to help produce some of that. But just looking at the main purpose, right? If you're trying to differentiate just as an introduction between the two terms, agentic AI is more autonomous action and decision making, whereas generative AI, you're interacting with the tool, right? A lot more. You're providing user prompts and you're having a back and forth to create something new. So a little bit more about just Gen AI tool usage. We touched on this a little bit, right? Just within other types of technology, not necessarily like electricity or the car, right? We remember how ChatGPT took about 2 months to reach 100 million, and just how much quicker that is to reach 100 million compared to even Instagram. Instagram, I think it's a really popular social media application. It took 30 months, right, to reach 100 million. TikTok, very global, took 9 months. And again, ChatGPT, less than 2 months. So just want to touch on a little bit AI adoption and cloud adoption similarities. So specifically integrating AI into enterprises, right? And we'll talk about ethics later on. It does raise concerns similar to past data management debates, right? So do we want to use public AI or internal AI, right? Do we want to build our internal large language model? Do we want to leverage maybe an open source one or a closed source one? And this really mirrors, if you recall, right, the earlier public cloud versus internal data center dilemma. So of course, there's some concerns like data security, right, organizational conflicts, how long it could take to deploy an internal AI versus an external, maybe leveraging something public, right? Maybe what kind of external providers are available, right? So these are all considerations, and there's actually a lot of similarities, right, between cloud adoption and AI adoption, and we'll touch on some of these concerns again in future modules. So some specific considerations, right? It's not as simple as maybe some leadership within your organization, if they're really pushing AI adoption, right, is what it looks like. So maybe some individuals think, okay, you have data, great. We have some sort of AI, and boom, we have this immediate value, right? It's a lot more complicated than that. I think we all know that. This is grossly, I think, oversimplifying it. But there's a few other considerations that we need to keep in mind as we're adopting AI, specifically the data itself, right? The selection of it, the sourcing, the synthesis. Maybe our organization internally does not have enough data to build a accurate AI model. So where are we going to get this type of data to augment maybe what we have, right? Does it even exist? Do we maybe need to generate some of that synthetic data to then be able to create like these models that are useful? And this is all built on some constraints, right? Of course, depending on the industry, coming from aerospace, security is huge. Maybe the data you have historically, right, is biased. There's been some use cases that have come out and, relatively recently where organizations implemented AI for human resources, specifically hiring, right? And they trained their model based off all this organizational data, and they thought it was great. But what they failed to realize is historical bias. So although the data was great, it was labeled, it was perfect, right? It was historically biased towards younger candidates, right? So being able to really take a look at the data and make sure there's no underlying bias in that data that can negatively impact your model is really important. Then you have ethics and transparency, right? Of course, if you want your team to trust your AI and interact with it, maybe you should show them how it works, right? What machine learning algorithm is it using? What data source is it pulling from? That transparency could be important. Then, of course, legal ramifications. And then the data science, the AI piece, right? There's really the data engineering and then the modeling, right? Within data engineering, you can explore the data, right? Clean it. We want to normalize it, right? And then modeling, like we mentioned earlier in the machine learning life cycle, you select a model, you train, right? You want to evaluate to make sure that it's predicting or doing its task well. And then from there, you might want to tune it. And then finally, you're able to operationalize it. And that's where you're able to get the value. But it's really important as well that, and we'll talk about this, I keep saying later on, there's just a lot to discuss. But it's really important that you monitor your models, right? Because if you don't and you just leverage old data, you could have what we call model drift, right? Where you're using old predictions, but reality has shifted a little bit, right? Due to some sort of causes. Likewise, you also want to be able to, from a management perspective, justify the cost of these models and these tools and the people working on them, right? So being able to calculate more or less a return on investment from adopting AI technology for your projects becomes really important. Just touching on how AI can even further transform even, say, product development, right? There's three ways organizations can first, if you're just testing out AI, you can use it to enhance existing workflows, right? Like we mentioned the example with Jira, right? We can augment our software ticket writing by leveraging AI. Then organizations can actually leverage AI innovation itself to maybe identify new products, identify new systems, right? And then if you get really advanced or maybe, cost permissive, you can actually have AI have end-to-end autonomy, right? So you might have these different agents that help with product development. Then they might launch and integrate a product. They might conduct, another agent might do marketing for the product. Another agent might more or less, right, be that chatbot, maybe some operations support and maintenance. Then you might have an agent that sunsets a specific product and then starts another one, right? So you can really have different levels of AI transformation. And as part of Gen AI and its adoption within organizations, we know that Gen AI, it's reshaping the time to value paradigm, right? It's really enabling organizations to move quicker. And it's a key driver of this technological transformation. So the development of AI, right? It's really it's fundamental as the creation of the microprocessor, right? The personal computer, the internet. It's really synonymous or becoming synonymous with a lot of these pivotal technological inventions. And there's been a lot of institutions like the Project Management Institute, they're actually coming out with a standard for AI management, right? But there's been lots of different frameworks established for not just Gen AI, but broader AI adoption, especially for project management, right? Correlating with engineering management. So what are some leadership implications, right? We know that fast adaptation of emerging technologies is really critical for organizations to maintain competitiveness, right? We know that Gen AI, it's really transforming industries by the 7 patterns that we saw, and it has a growing role in areas like DevOps, right? So there is a lot of opportunity to even increase competitive advantage for leaders in all these different industries. There's several frameworks here, right? Like the scientific method, this OODA loop, the lean methodology that can really help organizations prioritize continuous improvement and rapid decision making. And integrating AI platforms into existing systems can allow organizations to operate with greater speed, right? Maybe reduced overhead. And it's really important that you think about AI infrastructure if you're implementing it, that it can be scalable, right? It needs to be utilized well in all areas of the business. And that really hinges on trust in AI systems, which is why we'll talk about really the transparency, right? Trustworthy AI systems. We know that Gen AI, it can augment decision making. So leaders, we of course face complexity in decision making. So there could be conflicting expert input, right? And resource intensive strategy implementation. And Gen AI can streamline this because like we saw with the limitations of the human brain with working memory, right? Short-term memory, it can synthesize these large volumes of information to enable more informed and quicker strategic decisions, right? So it's really shaping this technological landscape that really brings together accessibility, affordability, and scalability. So some specific Gen AI use cases touched on a lot of these already. They're part of those 7 broader patterns, right? But you can have interactive sessions, right? With a specific chatbot, right? You can summarize large volumes of text. You can translate language. You can teach and explain, right? Maybe you're not understanding a specific, calculus problem, right? And maybe ChatGPT can explain it to you, right? You're able to brainstorm and create new ideas. It can be your virtual assistant. Helps with content creation on the software side, code generation, application development, like we saw with some other tools, rapid experimentation, academic research, definitely, right? Mentioned how it can at least maybe help summarize a lot of new research articles that are being published to generate meaningful insights. Customer support, right, and blockchain operations. So there's a plethora of use cases out there. Now, just touching on a little bit about the future role of AI and still arguing why we're in such a pivotal time right now. This study here on the right-hand side was done in 2023, so I'm sure the numbers are a little bit different now, but there's a lot of potential for integrating AI, right? Because many organizations, specifically this survey was done with engineering organizations, we can see how some of the tasks, right, are not prevalently augmented with AI in many organizations, like creating proposals, right? Less than 25%. Summarizing documents. I think that's a key area, right? 17%. Developing 3D models, 15%, all the way down to on the software side, assisting with code compliance checks. I think it could be pretty useful, right? But 7%. And I think a more glaring one is, hey, we currently don't even really use AI at 52%. So there's a lot of potential opportunity to be gained by organizations that haven't fully leveraged AI yet. Some future AI trajectories. I think by now we can tell that AI is not just a tool, but really a transformative force that can reshape how we think, act, and interact at the human level. And you can see here, there's this trajectory of technologies model, the TOT, that aims to classify how AI evolves in society based off feedback loops and intentionality. So if you are considering a AI initiative, right, you might consider where it falls on this matrix, right, where the upper part here is, well, people change technology, right? Maybe you have positive feedback or negative feedback, and then how technology changes people, right? So some specific areas that you can look at are agentic reasoning, those collaborative AI agents, multimodal intelligence, right? So text, speech, images, embodied AI, and this is more humanoid robotics, right? And then enterprise prototyping, so just some other domains. So change management in the AI environment, you can imagine, is really important, especially with how quick technology changes. So it's really essential for organizational transformation within, again, the AI environment. And it requires not just new technology, but these cultural shifts, right? I think a lot of times, and we'll see in the subsequent slides when we talk a little bit about potential job displacement and job categories, right? Is there could be apprehension in accepting AI as, a change agent within organizations. So it's really important that you develop a change management plan, like you can see here, for AI integration and some specific areas that you can touch on, right? Maybe identifying the stakeholders early on. You want to communicate effectively. So you might have, I can see here later on, a roadmap. What are we accomplishing here? You want to provide training and support because AI initiatives oftentimes fall flat, even though the concepts might be great because they're not adopted, or individuals don't know how to leverage these tools. They're hesitant to leverage these tools. So providing training and support is really important, obviously with a long-term roadmap. Then once you have the actual initiative live, right, you want to monitor progress. It's like we touched on earlier. You want to make sure you can measure ROI, not just from a financial perspective, but maybe from a adoption perspective, right? What percentage of your engineers, your organization is using this tool or system? You want to address any resistance, right? And then you want to continuously improve, right? We know that. So organizational process modifications due to AI can be categorized as changes, right? Maybe to the customer experience. You might have changes to operational processes, like again, we mentioned with the Jira example, or changes to the business model. So customer experience changes focus on using Gen AI for that faster support, right? Content creation, maybe that hyper personalization that we talked about. Operational process changes leverage AI to automate and perhaps have advanced analytics, streamline tasks, right? Make Jira suck less. You can have business model changes. So this can change the full automation of product life cycles. Like we saw earlier, maybe you use AI agents for different areas of the product life cycle and fully automate it. You can use AI for research, right? Marketing, just these other business areas. And that takes us to touching on a few different types of AI maturity models. So once you start implementing AI within your organization, or maybe you're interested in running an initial assessment, maybe you have a few AI initiatives out there already, you might want to leverage a maturity model to see how you're doing, right? So the first one here, and again, we'll touch on two or three of them, is the AI capability maturity model. And this helps organizations assess and improve AI readiness across several operational areas. So you can see AI is in the middle, but then some other operational areas include the people, right? The infrastructure, the software deployment, the security piece, the data management, and then the algorithm development. And just like other maturity models, I mentioned similarities with project management maturity models. There's usually 5 levels where one is usually pretty poor, right? Maybe specific to an individual project, individual team, right? All the way to level 5, where it's fully optimized across the entire enterprise. So you might say, oh, the AI ready workforce might be at a level 1, right? So maybe that's an area I need to focus on. Maybe my machine learning operations is really good, but I just need to get the people on board. Then another maturity model is the Mitra AI maturity model. So this helps organizations assess and then guide their AI adoption journey. So you're focusing on, you can see 6 key pillars here, and it's broken down. There's a few dimensions within each pillar. And you can see here again, it's those 5 maturity levels, where level 1 means we're not quite there yet, all the way to level 5 means we're the best, maybe industry leading. So the 6 pillars here, you'll see similarities. That's why I included a lot of these, is the ethical use of them, the strategy and resources. So maybe people, right? The organization, technology, data. Data is usually key, right? And then the performance and application. Here's another one. So this is the Gartner AI maturity model. Again, you can see the different levels, still 5. And this defines the AI maturity by representing a progression from experimentation all the way to full enterprise-wide integration. So level 1, again, being awareness, there's some AI interest, all the way to AI is a part of the business DNA. I know in my organization, right, we're starting to adopt AI, so maybe we're a little bit more on the operational side because now we have an AI directorate, right? There's a VP of AI. We'll talk about a lot of these new roles that come with AI integration, right? There could be an ethics officer, et cetera, but there's now this discrete function within the organization for creating and then monitoring these AI initiatives. And of course, once you implement AI, you may want to monitor some key performance indicators. And these key performance indicators in the figure here, they fall into 2 broad categories. So the first one is efficiency. And you can see here is defined by time, cost, and resources. And then you have effectiveness. And this is defined by accuracy, quality, and clarity. So if you're thinking about how to quantify that ROI, maybe you use some of these KPIs, right? Where you can quantify time, meaning, well, based on just humans doing the work, right? How much time is saved by using AI, right? What's the project completion time? How much time do my team members get now by not engaging with Jira 24/7, right? What's the cost, right? What's the resources? Same thing with the accuracy, right? Maybe if, like in my example, we were writing proposals, right? What's the accuracy of the proposal template that the AI system generates, right? Is it precise, right? Is it correct? Did it miss a few fields that I have to add later? Was the quality good, right? So you're able to quantify some of these metrics to really help gauge the effectiveness and the efficiency of your AI initiatives. And when we talk about organizations integrating technology, it's really useful to look at technology readiness levels. This is a method of estimating maturity of technologies, and it was actually originally developed by NASA back in the 1970s. Technologies often start at the bottom level here in this thermostat graphic, technology readiness level 1 through 4 in this lighter purple color. And these are usually led by universities and research institutions, right? Where we're just trying to identify maybe a new algorithm and we're trying to research to prove its feasibility, right? Maybe we develop preliminary technology for it, right? Then you can see at technology readiness level 5 and then 6, right? You're able to test the technology in a controlled environment, make sure it's ready to be functional, maybe within an organization and in these environments, right, that closely resemble real world settings. And then maybe more of the adoption now, right, towards the end is now when, okay, have prototypes of our AI initiative at the organization and we can actually use it at a broader level. So being able to understand maybe where your organization is at or what the technology you're looking for adopting, where that's at, right, can be really beneficial. So we've been talking a lot about really the benefit, hopefully, of AI in terms of its actual functionality. But now the last few slides here, just wanted to pivot a little bit more and talk about the broader economics of AI and how it can impact our organizations at the global level. Then we'll conclude with a little bit of a job argument as well. So you can see here that the global artificial intelligence market, right? Like it's really experiencing this huge growth, and its expansion is expected to go from 390 billion last year all the way to over 1.8 trillion by 2030. So there's this insane growth just around the world, right? AI could contribute up to 15.7 trillion to the global economy by that 2030 timeframe, which to put it in perspective, right, it's more than the current output of China and India combined, right? So there's definitely a lot of areas here that you can see across the world using this graphic here. You click there, study done where AI is really being developed. So just as a preliminary ROI quantification, right? And we'll do an exercise on this in a few modules just to see the cost of implementing some AI, is we can actually save a lot of cost, right? So customer service agent, right? If you're trying to answer a question, the Gen AI cost time, right? It's usually less than a second, right? The response is almost instantaneous. Costs a fraction of a dollar, right? Where the human cost might be in the low teens of dollars, right? Because it could take minutes or hours for that conversation to occur. Some other use cases and just ROI, I won't go through each one of these, but a graphic designer to create an image, right? To be fair, some of the images that, say, ChatGPT or similar tools create, especially if you're looking at spelling in those images, can be off a little bit, right? But you can see, regardless, it's a lot quicker to create using these types of tools. And now we're getting to more expensive domains, right? Like a lawyer. You know, if you're summarizing a legal document, it could cost hundreds of dollars, right? Whereas Gen AI, again, could be a lot cheaper. But once you get to more of these advanced applications, like with more implications as a result, like summarizing that legal brief, as a doctor, maybe diagnosing someone, as an engineer, maybe generating a design, right? That it's really imperative, which is why I put this course together, to understand the frameworks and some of the algorithms behind what that AI is doing, right? What algorithm is it using? What data set is it using? How accurate is it, right? So we can build the trust with these systems to then be able to leverage them for, we can call this, let's call this more higher risk applications. And just showing just a use case from Klarna, how they were able to use an AI assistant here and they saved a lot of money. Looks like they were able to drive even $40 million in profit. So some organizational Gen AI creation and procurement, just some interesting statistics here. Again, there's, I think, 14 of them, 16 of them. So just touch on the ones in bold here. But organizations in the top right figure, their budgets for Gen AI, I should just say AI in general, they are growing exponentially. So organizations are planning to increase their spending on these initiatives by 2 to 5 times in upcoming years, which is why that second part of the course, I'm really hoping that you think about a practical application that you can bring to your organization. And when it comes to a Gen AI, or just AI, I should say, initiative. Then the figure in the blue there, organizations, they're adopting more of this multimodal strategy to avoid lock-in. So basically, you're trying to not rely on a single vendor. You want to stay flexible because, like we mentioned earlier, AI is moving really, really fast. So you want to avoid lock-in, right? You want to be able to be modular. Think about open systems architecture, right? And a modular design. Then the one here in the green, right? Fine tuning and retraining models is seen as key to optimizing AI tools, right? So a lot of times organizations do not create their custom models. And we'll talk about later on just how expensive it is to create your own large language models, right? You may want to fine tune maybe an open source model, right, for your application. Save you a lot of money on infrastructure as well. And we'll talk about retrieved augmented generation, that's RAG, but that's another approach that we can use to generate information. And then in terms of ROI, right, the actual metrics, the measurement of ROI is still evolving. So organizations rely on proxy metrics, like we saw some of the KPIs potentially, right, like productivity, efficiency, and customer satisfaction. And just specifically what organizations are doing now, right? They're more than half, right, believe ROI is positive, but they're not precisely measuring. So you can see that's a huge gap. That's a fallacy in itself. You should not just assume all AI initiatives have a positive ROI, or at least maybe they start negative and they then go to positive, or the inverse, right? You need to have metrics to measure ROI in some way throughout the entirety of that initiative. Some of them focus on ROI from cost savings, right? Maybe from new revenue opportunities. And some of them are just blissfully ignorant of that. So what are some of the technology trends that are driving the business transformation? We predict that some research has shown here, I believe this is, the World Economic Forum, that by 2030, 86% of employers expect AI and information processing technologies to transform their business more than any other technology. So specifically, the share of the employers surveyed, right, and some of the technologies they believe within the AI space will be most disruptive here, right? AI information processing, of course, being the highest. Maybe some of those, the robotic systems, almost like the autonomous systems, right? Like self-driving cars potentially at 58%, right? Even in the aerospace domain, there's a lot of interest in autonomous air vehicles, right? Whether they're UAVs, a C-130 gunship, right? That's autonomous. There's a lot of potential there. You can have energy generation, storage, and distribution, right? New materials and composites, maybe making some of the infrastructure cheaper, right? And that ties in with semiconductors and computing technologies and some other elements where, right, AI can be implemented. And this takes us to that other learning objective of upskilling and being able to promote your own AI literacy. Specifically, the global demand, like you can see in the figure for Gen AI, and I should again say AI in general, right, is rising rapidly. And actually, India and the United States are currently leading, but you can see that there's a lot of enrollments, right, in these AI learning courses, right, between different organizations. And that takes us to, well, what discrete activities, maybe roles, right, can AI substitute? So specifically on the right-hand side here, we can see that with some of the, you can see the brown here, AI has a high capacity of potentially augmenting, right? Whereas the lighter blue is the very low capacity. So you can see obviously artificial intelligence itself, right? AI can augment that. What's this marketing and media, right? They can generate a lot of advertisements likely. Programming, it's maybe 75% augmented, right? AI can help generate code. And then you can see more of these creative tasks then are still more human focused, and there isn't a lot of data or predictions that are saying that, oh, AI is going to take over maybe some of these facets within the organization, right? For example, I think towards down here, creative thinking, right? AI can suggest some novel ideas, maybe if you've played around with on the engineering side, generative design, right? Like Autodesk Fusion 360, it could create a few ideas, but the majority of creative thinking is still predicted to be retained, right, by the human. Likewise, something completely human, you would say, like empathy and active listening, right, will likely continue to be human-centered. But you can see here, again, how AI will, over time, more or less augment some of these other skills, even systems thinking, right? And being able to synthesize and think big picture, AI can really help augment that. And that takes us to workforce disruption. So as AI continues to evolve, right, and become more cost effective, it can likely begin displacing humans in certain roles. And more or less, just some interesting statistics here, 63% of CEOs believe that AI will have a larger impact than the internet. So just crazy to think about even an investment opportunity, right? By the mid 2030s, as AI advances and becomes more autonomous, 30% of jobs, right, and 44% of workers with low levels of education will be at risk for automation. And that takes us to the figure on the right-hand side here that although there could be some disruption in the workforce, at a net value, research argues that AI may not lead to more unemployment because AI technology can create more jobs than it automates. And to bridge the gap between the two, right, is really about the AI literacy. So you can see some growing demand here. Of course, data analysts and scientists, AI machine learning specialists, right? Really a lot to do with leveraging, using AI, right? Business development professionals that augment AI in their workflows. You can see the decreasing job demand. So some jobs that may be at risk of being removed or at least more supplemented with AI, right? Data entry clerks, right? Administrative and executive secretaries, especially with the arrival of tools like Microsoft Copilot, right? To help with meetings and so forth, emails. Accountants and auditors, right? General and operations managers, mechanics and machinery repairs. And this is maybe when we're talking more autonomous systems coming online, helping even in the warehouse nowadays. So this is estimated as a result of this potential shift that 50% of the global workforce will need reskilling. So learning again, some of these technologies and other skill sets. This is just another interesting graphic from the World Economic Forum that shows that adopting generative AI in general, of course, with its potential to increase individual worker productivity, could actually fuel significant job growth, right? So, like we talked about in the bottom left, maybe some of the higher automation, right, for AI and the declining roles, right, like bank tellers, right, telemarketers. We talked about administrative and executive secretaries. But where on the right-hand side here, the more extreme, where you have more of the highest augmentation with AI and a growing field, right? Database and network professionals, right? Database analysts and scientists, the machine learning specialists, mathematicians, right? Engineering is up here as well, right? There's a lot of potential to leverage these tools within our domain. And that takes us to obtaining and retaining AI talent that we identified the gap for on the previous slides, and just further cementing the case for AI literacy, that LinkedIn News identified it as the fastest growing skill in the US, which again reflects the increasing demand for individuals who can leverage AI technology. And that's why understanding that ecosystem that we talked about with the AI infrastructure, right? Some of the technologies and then the horizontal and the vertical applications, because then you can be robust across various industries. So as organizations transition into this AI era, it's imperative that we attract talent with the right competencies, right? So what are some of these competencies that we're looking for, right? So we want to make sure you have strong organizational context within your organization. You want to make sure you attract and retain talent. So more on the management side, right? You want to make sure you have training programs, mentorship, and the like. A lot of these top talent, they want autonomy. So they want to work independently, right? Some of them might want flexible work schedules. You want to offer career advancement, right? You want to have flexibility in technology development, obviously competitive compensation, and really make sure that you have a top talent within your existing talent pool because of the poaching, right, that can potentially happen. So you want to make sure that you have career roadmaps for some of those individuals. And again, the future of jobs, how we talked about the emphasis of 50% of the global workforce needing reskilling. There should be an emphasis on digital fluency, right? Emotional intelligence and creativity, because the half-life of skills, right, shrinks to less than 5 years, right? And non-AI workflows are becoming increasingly obsolete, right? So the half-life of a learned skill is 5 years. So this again is really imperative. This whole slide just talking about how it's really important that you continue to learn these new skills, especially in the AI domain, such that you can take some of these new roles like prompt engineers, AI ethics specialists, chief AI officer, right? There's a lot of opportunity with the growth of AI. So I know this module had a lot of topics, but just wanted to really summarize this positive argument for AI, right? We understand that AI has the potential to expand access, really allow humans to perform more complex decision making. And this can actually support the revival of some middle class jobs, right? AI can certainly automate certain skills, but I think that the acts of the human performing a skill, even though some of the actual skill might be automated, can help enrich personal and professional lives, right, in ways that automated systems cannot replicate. So even though AI might be better at language translation, doesn't mean you shouldn't learn another language, right? It could still help you with your personal fulfillment. But again, AI as a whole, there's a lot of opportunity to augment our current roles, and especially given the limitations of human cognitive abilities, right? This could be a really useful way to really increase our efficiency in the workplace. So some ethical considerations. Again, we'll have a whole module on this, but there's a lot of opportunities and ethical challenges that organizations need to navigate with AI. So think about the fairness of it, the transparency, the accountability. This also goes to bias and data sets that we'll talk about, right? Making sure that you're promoting innovation while protecting human rights, right? Societal well-being, especially if you're creating large language models, excuse me, say like OpenAI with their ChatGPT, right? You want to make sure you have guardrails in place, right? You don't, like if someone types a prompt, right? How do I create a bomb? Maybe they flag that, or there's sensors in order to, prevent maybe that type of information from being generated. So to address these ethical challenges, right, frameworks should be created to guide the development, deployment, and use of AI responsibility. And we'll talk about how organizational governance in this AI space can help achieve that. So how do we establish AI credibility and presence? So demonstrating value to the community with AI, right, requires consistent relationship building and contributions, which over time can build trust, goodwill, and enhance organizational reputation. So again, just summarizing, that trust is one of the key elements when you're trying to really have great AI adoption, right? Making sure that the users understand how the AI works, how the AI system works, and that you're not creating harm to that broader community to really help build your credibility. And it's really important to learn continuously in the AI environment. So having this growth mindset that's rooted in the belief that abilities can be developed, right, is really important. So you can see that if you're trying to preliminarily adopt or push AI within your organization, that you have behavior, perspective, and mindset, that they're all interlinked. And specifically, if you shift one element like your behavior, this can change your perspective. Like reading the graphic here can impact your mindset. So individuals with a growth mindset, maybe you volunteer to be on a pilot team for an AI initiative, right? You're going to be able to shape your perspective and perhaps transform the organizational culture to accept AI within a lot of your projects. Just wanted to leave you here with some strategies for technology learning. I personally use Alpha Signal AI, but there's, again, so much information, both about new technologies, right? New papers that are being published, new startups. So if you're really passionate about the AI space, I recommend that you try and leverage some of these sources in order to really augment your own learning about these tools and systems. For example, if you're interested in technical news, right, there's a few potential sources. Maybe you're interested in more investment opportunities or what new companies are doing, right? There's a few links here as well. Maybe you're interested on the software side of things. There's a few AI related links here as well. But this learning and using AI, right, it's not a one-way thing. It's a dynamic process where you need to be actively engaged, right? So you can help foster this continuous growth mindset and actually have this active engagement because that's where meaningful learning actually happens. So just to summarize what we discussed, right, we saw the landscape of artificial intelligence. So we talked about at a high level, machine learning, deep learning, NLP, and Gen AI, and then a little bit about agentic AI. I know it was a lot, but I just really wanted to set the foundation because now in subsequent modules for the first half of the course, next week we'll discuss machine learning in detail. So specifically, we'll talk about, again, unsupervised learning, supervised learning, reinforcement learning, semi-supervised learning, different algorithms, how they work, right? So we'll get into some of that detail. Same with deep learning and the rest. We also saw how cognitive limitations of human decision making really justify the growing need for AI integration. It can, again, really help augment our decision making due to some limitations of the human brain, really help offload some of that working memory, right? The short-term memory. Then we took a look at the historical evolution of AI technologies. So we saw both the infrastructure and how that grew, and then the concepts of AI themselves and how when both of those were at a sufficient level, right? That's why we're really seeing the AI boom right now and not necessarily in the 1950s, right? Where technology wasn't quite there and we just discovered or realized what a perceptron could be. We saw how AI is being adopted across industries. So specifically, we took a look at those 7 patterns of AI. And again, if you're looking or starting to brainstorm for a potential AI initiative, maybe seeing how it can align with one or more of those patterns. Saw some more discrete use cases, right, for Gen AI as well. And then how you can leverage layers of AI for those specific use cases, say at the infrastructure layer, right? Like we saw the technology layer, maybe the horizontal layer, and then an industry specific application. Then we saw how AI maturity models can be used, right, for responsible AI deployment and governance. There's many AI maturity models out there, but maybe if you're interested in applying AI in your organization, maybe seeing where you're at right now and where you want to be and what specific then areas of that model you should focus on. And then we saw from a broader perspective the impact of AI on the global workforce. So maybe some emerging roles, the reduction of specific roles, right? And then the ultimate argument for reskilling and really the importance of this growth mindset, just because AI is so dynamic and the environment is always changing. So touching on some of the deliverables, again, if you could please complete discussion board 1. So they're always going to be due on Sunday in this course, and then your initial response is going to be due Fridays. If you could also respond again to at least one peer by Sunday, just to have a little bit of a discussion. And then this first half of the course will always have a quiz. And the quiz, if you've took ENGR 502 with me, they're very similar in terms of structure. So they're 10 questions, excuse me, and they're multiple choice, true or false, right, that pertain just to this module. There are lots of certifications now also with AI, like the Project Management Institute has an AI certification now as well. So that's why I kept the time limit on here. Just if you're interested in pursuing a certification, just to have that type of a setting as well. And again, I made the textbook. It's really optional material. I think this specific book is a little bit more trivial on the application side. But if you're interested in following along, right, I did provide some of the reading from the book. And like I always have supplementary articles. You're not going to be quizzed on any of the supplementary articles or the textbook itself. The quiz questions will be derived from the slides because I try and aggregate all the material here. But if you're interested in some of those topics a little bit more, right, maybe the economics of AI in this case, maybe some preliminary overview, I did post a few articles in Canvas as well. But with that, I did want to pause here and just ask if there's any questions either about the material or any of the assignments for the week. All right. Well, if anything does come up, please do feel free to reach out. I do my best to try and respond within 24 hours. But otherwise, I hope you have a good rest of your week, and we'll be here same time next week. Thank you for your time.